Hi there, and welcome to the ForES project's second webinar. My name is Owen Small, Research Assistant and Project Manager. Today we focus on our decision support tool, meant to assist Irish foresters in understanding how management decisions impact the trade-offs in ecosystem services. To begin, I'll hand it off to our PhD researcher, Kathleen, who will explain the modeling behind the tool.
Hello, my name is Kathleen Conroy, and I am the PhD student on the Forest for Ecosystem Services, or the ForES project. This is a DAFM-funded project and a collaboration between Trinity College Dublin, University College Dublin, and Coillte. The goals of the project are to measure ecosystem services provided by forests and understand how different management decisions can change the flow of ecosystem services. One way to do that was by creating a decision support tool. The engine of the tool is a Bayesian network model, which was developed by researchers and experts. Today, I will talk to you about how we created this tool, and my colleague Matthias will discuss how it was integrated into a decision support tool. We'll talk about some background of forestry in Ireland. Then I will go into how we selected certain ecosystem services. After that, I'll talk about what a BBN is. Then I will discuss our BBN. And then Matthias will talk about the use of the BBN and the decision support tool. Of different factors, forestry in Ireland was historically low, reaching almost 1% of land cover at the beginning of the 20th century. However, in the 1940s, forests in Ireland began to grow immensely and reached 11% of land cover today, and there are plans of continuing this growth into the future. Even with the forest cover of Ireland at an all-time high, it is still significantly low for EU standards. Question to keep in mind at this pivotal point in Irish forest history is, what should forests be managed for? What ecosystem services should they provide, and how do we manage them for such? Two outputs of this project, and they are both reliant on ecosystem services. So we knew early on we would need to ask our stakeholders which ecosystem services they wanted us to measure and use. We decided we could measure several and decided to follow the layout of Ireland's Forest Strategy 2023-2030. In it, they have 5 pillars for forestry: forest for people, forest for nature, forest for wood, forest for climate, and forest for economy and rural development. Because of the scope of the project, we decided to remove the final pillar and just focus on people, nature, wood, and climate. We provided a survey for our stakeholders separated into private and public sector. Luckily, they chose the same ecosystems for each pillar, which made my job much easier. So now we had the task of creating a BBN for the 4 ecosystem services, one for each pillar. They were: was recreation-related services. For nature was wild animals, plants, and other biomass provisioning services. For wood was wood provisioning services. Finally, for climate was global climate regulation services. Take a couple of moments to explain what a Bayesian network model is. So what a BN is a probabilistic graphic model which shows the relationships between different variables and also the dependencies of them. So it shows how a variable affects another variable based on the state that that variable is in. So there are some rules when using BN models. They cannot have feedback loops. One of the really great things about these models, though, is that you can use multiple data types. And that was helpful for our project because early on we kind of realized that we weren't going to be able to use a lot of data from the field or literature data, and we were going to have to rely almost exclusively on expert elicited information. And these kind of models can actually really use that information quite well. And it's also related into the Bayes theorem, which is the probability of variables impacting each other based on the states that they are in. With the final ecosystem services selected, we were very keen on making the models. We knew we might have issues with getting the amount and type of data required of the models, and we would need to employ expert elicited information. We also found out rather quickly that we would need their help from the onset, including creating these models. This is because researchers know how things should work in nature, but we needed information of how they actually work in real life. So researchers did a couple of preliminary models internally, held a couple of workshops, got some inputs of how mechanisms work, and then they created a few rudimental BBNs for each pillar. The researchers then sat with experts for each pillar and they discussed what was missing in the model and what needed to be included. After many one-on-one meetings, we finally got the BBNs finalized, and these are the models that we produced. It's the Global Climate Regulation Services model. I'm just going to kind of talk through, it's a little bit complicated, but I'm just going to talk to what the different boxes mean. So the purple boxes, those are management decision boxes. These are boxes that the user can actually preset. They can put in different forest management decisions to see how that would affect the end outcome. The green boxes then are site characteristics. So these again are boxes that the user will preset, and they will have to have this information on hand in order for the tool to run correctly. So the purple and green boxes are boxes that the user puts into the model. That leads to these blue boxes. So the blue boxes are intermediate nodes. So underlying each of these boxes is a conditional probability table. So these tables are actually the statistics that go into the model. So this is the information that we elicit from our experts, the information that our experts give us that allows the model to actually run. Now, there's a few rules that we kind of had in place when we were making these models, just so that it would kind of make it a little bit easier to complete. So firstly, you can see that most boxes only have 3 arrows leading to it. Occasionally, we did have to break that rule, but what happens is when there's more than 3 arrows leading into a box, the tables that they have to fill in grow exponentially. I'll show you what one of those tables look like, but sometimes they can become quite large and arduous. Finally, the nodes usually have 2 to 3 states, so that means absent or present. Those would be a 2-state node, and then a 3-state node would usually be high, medium, low. Again, this was broken a few times for different reasons, but we try not to violate those rules too much, just to make sure that the tables could, excuse me, the statistical tables could be filled. This is the Wild Animals, Plants, and Other Biomass Provisioning Service model. Again, all of the colors and the connections are the same. So the green are the site-specific characteristics, the purple are the management decisions, the blue are the intermediate nodes, and the final diamond-shaped yellowish node would be the final ecosystem service. Here is the recreation-related services model. Again, the boxes are represented the same way. Finally, our wood provisioning services model. Mentioned earlier, under each of those intermediate nodes, which were the blue boxes, and the final ecosystem service node, which was the orange diamond, there is a conditional probability table. I'll show you an example of how one of those tables look now. Take a look at the wood provisioning ecosystem service model, and we just look at those 4 nodes that are circled. This is a zoomed in version to make it a little more clear. Here we are basically saying, how does storm damage, wind throw, and fire impact abiotic losses? But what we're really trying to understand is, how does the state of storm damage, wind throw, and fire impact the state of abiotic losses? So we can have all these factors present, we can have them all absent, or we can have a mixture. All of this will be captured in the table along with the probability of abiotic losses being in different states. So the CPT will look something like this. Look at the first column. We are saying storm damage is absent, wind throw is absent, and fire is absent. Then what is the probability that abiotic losses will be in a high state? What is the probabilities of it being in a medium state? And what is the probability of it being in a low state? This one is relatively easy because we would assume that the abiotic losses would be pretty low, given that there is no factors occurring. So this was the probabilities that the expert gave us. You can see they put the highest probability in the low abiotic losses section. The one kind of rule that the experts were given was that the columns all have to add up to 1, just so that the statistics work out. This was the information that the expert gave us on these 3 variables. And the thing just to note is, like, for the researchers, the absent, when everything's absent and when everything is present, that made the most sense to us. It's the middle area, which we were very interested in. When certain things are absent, certain things are present, what is actually happening at those points?
Thank you, Kathleen. Now that we know the modeling behind the tool, how do you take it from something like this to an interface more manageable and digestible? That's where our postdoctoral researcher, Matthias, will take over to discuss the user end of the tool and provide a demonstration.
Hi, my name is Matheus, and I will show how to use our web-based decision support tool created by the ForES project. We are using the hypothetical site Green Loop Forest for this example. In this site, we have a coniferous forest, a mixed forest, and a grassland area. Also, we have a trail, an official park area, and a public road nearby. So, we want to increase the recreation, and for this we have the budget of 3 golden peaks. To increase the recreation, we have 4 options. We can improve the quality of the trail, we can construct a parking area, we can put a bathroom, and we can put some signs that will include hazard signs, maps, and information signs. The costs and the options we get as a forest manager. The tool will not show the costs and the options available for each site. So, how to select the best option for our site? For this, we can use our tool. In the tool, we will create 4 different scenarios, scenario A, B, C, and D, based on the different options and different costs. This is the home page of the tool. We can find information about the model and the ecosystem service, also information about the project and how to contact us. In the sign panel, we have the option to select all ecosystem services and see the trade-offs between them, or just one of them. For this case, we'll select for people, that is the ecosystem service related to recreation. In the second tab, we can put information about our site. In the third tab, we can compare different scenarios. In the second tab, also have the option to upload a scenario that we already created, or we can put all the different informations for the site here. It's a long list of information that we need to know, but as a forest manager, we can have access and knowledge to know all this information. All the inputs are organized in the top are management decisions that can be linked for just one ecosystem service as for people, or can be linked to more ecosystem service as mixed. And the last part, we have site characteristics that are linked to the habitats and the nature part of our forest site. And it's a long list, and it's important to know everything before using our tool. Or put information about our site. It's all absent in this hypothetical site, or low because it's just one trail with low quality. About forest prescription, we can just see here the information about each type, but it's just an example, so we select anything. Also, we can see more information about different inputs. Here, we are just selecting some random information to run the statistical model here, but as a forest manager, we need to know all this information beforehand. Just putting some random thing here. So this is the first scenario that we will create, is how the green loop forest is now or last year. Here in the right, we can see the probabilities for the ecosystem service, and here we can see the selected inputs. Now we will save the scenario and create the other ones trying to increase the recreation aspect in our site. So for scenario A, we need to go to the top part and we will put a bathroom and all the signs in the area. With this, we will go down and run again the model. We can see that some probability changed. We will save and we'll go to the scenario B again. The scenario B, we will keep the bathroom, remove the signs, and put some parking area. And we do again, we run the model. We save the scenario and go to scenario C. In scenario C, we'll keep the bathroom, remove the parking area, and increase the quality of the trail. It's just one trail, so we can put as high in quality because the cost it will be low. So we'll run again. We save and go to the last scenario. It's removing the bathroom and putting signs, increase the quality of the trail, and putting a parking space. So we need to put everything here. We will run again for the last time, and we will save the scenario. So now we can compare the different inputs. Tab, we can compare the different scenarios. We can see the difference in plots. We can see the difference in the probability tables. Also, we can see the difference in inputs for each scenario. All the information here can be downloaded, all the tables and the plot, and this can be used in a report in the future. So for our example, we can see that scenario C is the best one. It has the high probability of providing high system service related to recreation, and there is a high decrease in the low probability. Also, the scenario D is the worst one, and we can see that the presence in bathroom makes a big difference. Also, we can select here a scenario that we can download it, and we can use this file to upload in this tab, in this part, so we can use this information in the future. As a result of our tool, we can say that scenario C is the best one for our forest site, and now we can create some report showing how to increase the recreation aspects. This ends our tutorial. Thank you very much.
Thank you, Mateus. Now, we've shown you the Bayesian model that we've developed and the interface that you can access to utilize and apply our decision support tool. To conclude this webinar, we're now going to discuss our tandem approach, how foresters can apply site-level ecosystem accounting and our decision support tool to optimize ecosystem services on your forest sites. We start with ecosystem accounting. If you've watched our first webinar on our natural capital accounting methods, you know that site-level ecosystem accounting, when data is available, can provide detailed insight into how an ecosystem has changed over time. It shows you the history of the site as well as its present status. If you have adequate data, high spatial resolution over multiple years, these accounts could allow you to make projections looking toward the future. But, as Kathleen covered in our previous webinar, such resolution in the data is difficult to come by. That's where our decision support tool comes into play. Using Bayesian modeling, we can help foresters make informed predictions on how management decisions might affect various trade-offs between selected ecosystem services. Together, both provide foresters a wealth of knowledge, through data and expert opinion, to make informed decisions on their forest sites. With ecosystem services becoming of greater focus and importance, these tools are meant to help Ireland meet afforestation and reforestation goals, while still prioritizing and valuing the many benefits woodlands provide. We here at ForES highly encourage you to utilize our decision support tool. It's currently being beta tested, and we're looking for feedback on its output. Use the QR code to sign up for access. Thank you very much for tuning in to the ForES Projects webinars. We hope these videos have provided a good understanding of our project and its outputs. Please feel free to get in touch if you have further questions or are interested in learning more about ForES.